All right, so let's go ahead and solve a Hess's law problem. I just set something up here, written out a bunch of equations, but again, really all we're doing is just taking a look at the net, and again, you can see the net down here. This would be given to you, and then you're given three equations. So let's say we have our first, second, and third equation. Notice that they are all also given a delta H. So what we're doing with the Hess's law is we're saying, let's take that look at that net and see how these equations, the 1, 2, and 3 equations, can make that net. So what you do is you just take a look at the net. So I'm going to look at that net and it says 2C. All right, so I look throughout my initial equations for the carbons. There's one. I'm not counting this. This is CO2. That's not carbon, only carbon. So I'm looking for all the carbons, none in the second one and none in the third. So I only have my carbon here. Now my net says that I need 2 of them. So since I need 2 of them and I only have 1 in my first equation, I need to multiply that entire equation by 2. Notice if I do that, I now have 2, 2, and 2. That gives me my 2 that I'm going to need. All right? Hess's law says if you do that to the equation, you must do that to the delta H. So I'm going to go ahead and do that right now. I get negative 787 kilojoules. So it's like we don't even have this anymore. All right? So that took care of my carbons, my 2 carbons. I now look to my H2. H2, there's none in the first equation. There's 1 in the second. I have 1. Any more H2s? Nope, there's an H2O, but no other no other H2s. Notice this equation has like a half O2. Again, basically I've given you that. I could have given you a delta H that would be double that, and I would only had 1 and 1 O. For our purposes, we're fine with the half. You'll see what it does in just a second. But so I had an H2, and that's what I need, and I'm good. Now let me take a look at my C2H2. C2H2. These are the only ones right here. Okay? Now, there's 2 things I need to take a look at my C2H2. First, I'm giving 2, and I can't have 2. I need only 1. So I'm going to divide this all by 2. So that gives me 1. That gives me 2.5 here. That gives me 2, and that gives me 1. I don't want to forget it. So notice I have 1 C2H2, which is what I need. I need to divide by 2 for my delta H. When I divide by 2, I get 1299.4. Of course, that's negative kilojoules. Okay? But the other little wrinkle is that, let me grab a different color. I don't know how well yellow will show up, so let me grab purple. Notice that my C2H2 is on the product, but over here, it's on the reactant. I don't think I can't believe I'm not moving enough. Motion sensing knocking me out. So notice the C2H2 is on the product, but over here it's on the reactant. So very simply, I can reverse my equation that now makes these on the reactant and these on the products. So my C2H2 is on the product. When I do that, though, I must change the sign. So this must now be a positive 1299.4. Okay? I think that's good. And now I would just need to add up the 3 different delta H's. I've got 2 of them that are negative. I should add those up and subtract from the positive one, since the positive one is less than the 2 negatives. When I do all that math, I get it's a positive 226.6 kilojoules. So that would be my delta H net, positive 226.6. What I also like to do real quick is just show you how these 3 equations become the net. Notice that the 2C stays 2C. Notice I have a 2O2 and another O2, so I have 2.5 on the reactant side. And notice when I flip this, I have 2.5 on the product, so those cancel out. So I don't have any O2s. Then I look to my CO2. I have 2 on the product And notice my 2 on the reactant because I flipped them. Those cancel. H2, I have it, nothing else to do with it. H2O on the product, notice it's on the reactant here, one of each. They cancel. And then the C2H2, notice it's on the product side. So notice all those equations and other things in the equations end up getting canceled. You don't have to worry too much about it. As long as you're basically going through your net and making the net happen, you're in good shape. The only thing I would remind you is, let me clear this up here. Let's say that in the first equation we have a carbon, okay? And in the second equation I've got some things and other things, and I have another carbon. And my net says I need 2. If I have 1 and 2 both on the net side, I do not need to multiply this by a factor because I've got 2 on the reactant side, and that would give me that. It wasn't that way in this situation, but just be aware of that, okay? You may see, you know, on one equation, and again, I kind of am making a mess here, but let's say on your first equation, you have 4H2O plus something else, and it yields something. And then on your second equation, you have reactant, and you produce 2H2O. And on your net equation down here, you have 2H2O on the reactant. Okay? You don't need to divide this by 2 because, look, if you have 4 on this side and 2 on this side, it cancels them on this side and cancels 2 of them, to which is what you would have needed. I hope we understand that. The examples we'll use and we'll practice, but realistically, you're just looking at your net equation, making that happen, and then adding up your delta H's. That's Hess's law in action.